In today's lesson, we're going to look at start to look at function notation, evaluating functions, linear functions, different ways to help us write equations of lines, because that's what we're going to look at more tomorrow as well. So if you recall, function notation is now f of x written like this, and it's the same thing as y. F of x and y mean the same thing. So before, like when we see y equals mx plus b, we could say f of x equals mx plus b. Or if we see an ordered pair as x, y, now it can become x comma f of x. So f of x is just the output. It's the same thing as y. It's just another way to write it. So here, we're going to find each value if f of x is equal to 3x squared minus 2x minus 7. So for some of these, we're just going to see values. Other times, we're going to see some expressions here. So when I ask for f of 5, what this means is substitute the 5 in wherever you see an x. So this becomes 3, and parentheses are important, 3 times 5 squared minus 2 times 5 minus 7. Then follow order of operations. We have to square the 5, which is 25, and then we could just write everything else out. Technically, we could have multiplied afterwards as well. 3 times 25 is going to give me 75. 2 times 5 is 10, minus 7. So here we're going to get 65 minus 7, which will give me 58. Now be careful with a negative 1. This becomes 3 times negative 1 squared minus 2 times negative 1 minus 7. Again, square a negative 1 first, so this becomes 3 times a positive 1. Next, I could do this, so then I'm going to get a plus 2 minus 7. So we get 5. 3 times 1 is 3 plus 2 will give me 5 minus 7 is negative 2. Now, what does this mean? This means if we were to graph f of x, this would actually give us a parabola. And what we just found are points on the parabola. So if I were to do a graph trace, I could plot this point right on there, 558. Over here, this would give me the point negative 1, negative 2. So again, the negative 1 here, the 5, those are the inputs. The 58, the negative 2, those are the outputs. Pause the video. You guys go ahead and try to evaluate f of negative 3. It just means find y when x is negative 3. Hopefully you just did that. And now to see the results, we'll have 3 times negative 3 squared minus 2 times negative 3 minus 7. Again, we square a negative 3 first. This becomes 3 times 9. Next, this will give me a plus 6 minus 7. 3 times 9 is 27. Plus 6 minus 7. We could do this 27 minus 7 is 20 and then add 6. Or 27 plus 6 is 33 minus 7 is back to 26. Now for this last one, f of 4x, again, that just means wherever we see an x, we're replacing it with 4x. So this becomes 3 times 4x squared minus 2 times 4x minus 7. All this means is we're still going to have an x or a couple x terms with our answer. First, again, I need to square the 4x. So this becomes 3 times 16x squared. Then I can multiply this, so minus 8x minus 7. Now 3 times 16 will give me 48x squared minus 8x minus 7. And that's all the further we can go with it. All right, next we're again going to try to look at functions, but this time read it over carefully and see what's a little different. All right, here they're telling us f of x is negative 1. So what does this really mean? They're giving us y is negative 1. So we have to complete the ordered pair x comma negative 1. So we have to find x. Over here, we were given x. So here we were given 5, and we had to find y. So here this is just a little backwards. So now what we do is, since f of x and y are the same thing, we're going to set, if we take f of x equals negative 3x plus 5, f of x is now negative 1. So we put the negative 1 in for f of x. And then we solve for x. So next I'm going to start by subtracting 5. This will give me a negative 6 equals negative 3x. Carefully divide by negative 3. And then x will give me a positive 2. So this completes the ordered pair, 2, negative 1. You guys pause the video. Very similar for B. There's a little bit of a difference with this, but pause it, see what you come up with. All right, so with this one, f of x is equal to 24. So when we start f of x equals 4x squared minus 12, now f of x becomes 24 equals 4x squared minus 12. Yes, this is a quadratic, but we don't have to worry about factoring yet or the quadratic formula. Because there's only a quadratic term, I can isolate it. So what I want to do is add 12 to both sides. So I'm going to get 36 equals 4x squared. Now, we could technically take the square root of each side, but I really don't want to do that until we get the x squared term by itself. So now my next step is to divide both sides by 4. So I'm going to get a 9, because 36 divided by 4 is 9. So 9 equals x squared. Now I go to take the square root, but remember, there's two numbers when squared that give me a 9. So x, I'm just going to flip this around, is going to equal not just a positive 3, but a negative 3. So this means I have potentially two points here. So I have a 3 and a 24, and then also a negative 3 and a 24, because squaring either 3 will give me a 9. All right, next we're going to just take a look, because tomorrow we're going to end up writing, tomorrow and Wednesday, we're going to end up writing equations of lines. So we have to look at linear functions. And right now, linear functions can go in 4 directions. So they have 4 different types of slope. So pause the video and just see if you could write out which one has a negative slope, positive slope, and then there's 2 other special kinds of slopes that I want to talk about as well. So for this first one, when it's going uphill always from left to right, it's increasing, so we say this has a positive slope. The one next to it, as it's going down or decreasing from left to right, this has a negative slope. Any horizontal line is going to have a slope of 0. So remember, slope is used by or represented with the lowercase m. So here the slope is 0. Now here when we have a vertical line, think of like there's no place to stand. There's no defined place to stand, and there's no more numbers. Numbers are either positive, negative, or 0. We ran out of numbers, so there's no number that's defined. So here we say the slope is undefined. All right, so let's recall. Slope-intercept form is y equals mx plus b. M is the slope. So if you remember, slope is y2 minus y1 over x2 minus x1. And b, do you remember what b stands for? That is the y-intercept. Okay, standard form is when we get both the a or the x and the y on the same side. So we write it as ax plus by equals c. Now there's some conditions here. A, b, and c must be integers. So that's why we had to go over all those number sets. A, B, and C are integers, which means none of them could be fractions or decimals. We don't want to see any fractions or decimals left in our equations. All right, something else. Now, the higher level the math class you get into, the less this really matters. But for right now, we're going to say A must be positive. It just looks the nicest when it is. And then something else we mention here is that A, B, and C have a GCF of only 1. Which means, let's say A, B, and C can all be divided by 5. We do that then. So we want to try to get them in the lowest terms. If they have a number in common, we divide A, B, and C by that number. Something else I want to take a look at too, equations of horizontal and vertical lines. A horizontal line is always going to be y equals some number. So I'll put it like this. Y equals, let's say, some number b. An example is y is going to equal 2. This means all of our y values are 2, and all the points line up horizontally. So here the slope, remember again, is going to be 0. So the equation is going to be y equals b, where b is some number. A vertical line, all of the x's are the same. So it's going to be x equals, we'll just say a, where a is some number. So an example is going to be x equals -1. Here the slope is undefined. So the direction of a vertical line is here. So that means all of these points have an x value of -1. Let's say this is -1, 2, -1, 1, and this is -1, 0. Over here, horizontal line goes in this direction, so if I have some points here, all my y's, so let's say maybe this is a -1, 2, maybe this is a 0, 2, and then we have a 1, 2, so all the y's are the same and the points line up horizontally. All right, point slope form is something you may not have seen yet. It comes from the slope formula. So if the slope is y2 minus y1 over x2 minus x1, what I'm actually going to do is just take away the y2's. I'm going to say y minus y1 over x minus x1. Then I'm going to go ahead and multiply both sides by x times x minus 1. So now these divide out, and I'm going to switch this around. I'm going to say y minus y1 equals m times x minus x1. And this is point slope form. What we need is a point, and we need an x1 and a y1. We need a point. So we didn't try to make a clever name or anything. It's just point slope form because we have a point and we have a slope. So it's y minus y1 equals m times a quantity x minus x1. So we're going to use this more with tomorrow's lesson. But for right now, I just wanted to show you where it came from, just a rearrangement, kind of like a literal equation. We just rearranged the slope formula to help us write this out. How is it useful? Once we solve for y, we get slope-intercept form. So rather than trying to find b separate and then put it back in, we just start with this form, and then it turns itself into slope-intercept form. All right, so with these two equations here, we're going to write each of them in standard form. So remember, that's ax plus by equals c. So first, I want to just get x and y on the same side. If you notice in the first equation, pause the video to write that down. X and y are not both on the same side. I always want x to go first. So I'm going to leave this 0.2x here. I'm going to add 0.3y to both sides, so I get plus 0.3y, and then that's going to equal 0.7. Well, now I have decimals, so I want to get rid of them. And if I just have, this is really 2/10, 3/10, 7/10. So if they're all over 10, I can multiply this side by 10. Then I can multiply this side by 10. Now multiplying a 0.2 by 10 is just going to give me a 2. It just moves the decimal point over 1. So this is going to give me now a 2x plus a 3y equals 7. So I have ax plus by equals c. I have no more decimals in my equation. A is 2, that's positive, and x and y are both on the same side. Now 2, 3, and 7 do not have anything in common, so the GCF is 1. If you want to try number 2 on your own, go ahead and pause the video and try that. Again, my first step, let's start by moving the x term to the other side. I want to write it first, and since it's positive over here, it's going to be negative when I write it over here. So I get a negative 2/3 x plus 3/5 y is going to equal a negative 2. Next, we could do this at one step, but the next easy step is I want the a to be positive, so let's go ahead and make 2/3 positive, which means I have to take the opposite of every other sign. So now it's going to be minus 3/5 y. It's going to equal a positive 2. Now I have to get rid of the fractions, the denominators here. So what can 3 and 5 both go into? 15. So that means I need to multiply this side by 15, and then I need to multiply the other side by 15. So multiplying 15 times 2/3, think 15 times 2 is 30. 30 divided by 3 is 10. 15 times 3 is 45. 45 divided by 5 is 9. Or you could say if 5 goes into 15 3 times, so then 3 times 3 is 9. And then I'll get a 30 over here. All right, so I have x and y on the same side. I have no more fractions here. A is positive. It's a 10 because we already took care of that. And 10, 9, and 30, all three of them don't have anything in common other than a 1. All right, so this worksheet is just called a Chapter 2 study guide. I actually got it from an Algebra 2 book. So please work on just 12 through 29. Graph all that is possible by hand, then check either on your graphing calculator or Desmos. And then I'm giving you guys another domain and range worksheet. I'm calling it Worksheet B. Just do the first 4. So I'll have these posted as separate PDFs. But here is a copy of the Chapter 2 study guide. Now notice over here on the left, it's giving you examples. So for 12 through 15, it says state the domain and range of each relation, then graph the relation and identify whether or not it's a function. So the first two were given relations, but 14 and 15 are lines. So I tell you what, you're going to want to turn them into slope-intercept form first and then graph them, if possible by hand. If not, graph them on a calculator. Now for 16 through 19, here you're given f of x, and you have different values to find for f of x. For 20 to 23, just state whether each equation is linear. Will it graph a line? If you can't tell, graph it on Desmos or your graphing calculator. Desmos will be easier for some of these. If it is a linear equation, graph it by hand. And then for the last set, 24 through 29, write each of these in standard form. Again, examples off to the left. So yeah, just get those in standard form. Please let me know if you have any questions.